Okay, so after we covered everything there is to know about JavaScript, we're going to start looking into taking a deeper look into some features of the language. And like every good course that starts with hello world, the second thing you do is explore the different variables and types that the language has to offer, the built-in ones at least. The reason is that because you cannot do anything without them, because that's what computers try to do. So computers just take data and try to process it most of the time. When they don't play porn, computers are used for processing data. Porn is also, by the way, form of data processing, because without it we wouldn't have videos. So in pretty much every program that you're going to write in every language, including JavaScript, you'll be doing some processing of data, of numbers, of strings, of text, whatever you use. So this is the basic structure of defining variables in JavaScript. We have the var keyword, then we have a name, and then we have some kind of value which we may or may not assign to your variable. That's we'll see more examples of this, of course. Data types. Important to understand what data types are. When we put a variable like this one, we actually allocate a part of the memory in our program's context, and we put some value into it. When we allocate some memory, we need to know how much, what's the size of the memory we need to allocate, and also how the program will interact with it. So for example, here we are defining a variable, and it's a number, and the value is 5. But unlike other languages like C#, for example, these things are very flimsy and loosely coupled when it comes to JavaScript, because you can make different variables hold different types at different times. So it could be a bit confusing. It doesn't mean that JavaScript is completely typeless. It has types. They're just hiding. So this is an example of how to allocate a number, which will have the number variable which will contain the number 5. So the basic data types that we're going to encounter, all kinds of numbers and strings mostly. So here we have a few examples of variables. The first one is a number which holds an integer value of 5. And down here we have another number which has a floating point number of 5.25. Basically all the numbers in JavaScript are floating point numbers, even if they're represented differently. We will see a little bit of tricks with numbers also later. But note that the first variable here, count, is first assigned to 5, and then it's assigned to the string hello. That's perfectly legal in JavaScript. In every other language, you'll have a compile time error. But with JavaScript, you can do whatever you want. Then we have another variable which holds a string, but this one is fine because it's not changing. Yeah. No. There is no int. Put the variable, just throw what you have, and that's it. There's only one keyword for defining variable. That's the word var. In C#, they came up with var pretty late. Before that, it didn't exist. But in JavaScript, the only variable definition keyword is var. And it doesn't mean that the variable isn't typeless, because of course there has to be a memory allocation, and there's some value that you're keeping. So there are types, and you can also determine what type the variable is. We'll see it later. But you cannot define in advance saying this is an int and this is locked. It's not strongly typed. So it's a bit tricky. And this statement, like I said, when you have a count of 5 and then count equals hello, is legal in JavaScript. Integer types. So basically, underlying 64-bit floating points are representing integers in JavaScript. There are some mathematical operations, especially bitwise operations that we'll talk about later, that actually take numbers and cut them down to 32 bits. But basically, all the numbers that are used in JavaScript are floating point numbers, even though they look like integers at some point. If you're assigning a variable to an integer, you know, integer is a whole number, right? It actually allocates a floating point number. So since they are since the data representation of integers in JavaScript, these are the two, this is the range of integers. It can go from -2 in the power of 53 to +2 in the power of 53. These are all the integers that it can support. We have these constants, number dot max safe integer and safe integer, minimum safe integer. These are numbers that are safe for calculations, and if you do calculations within this range, they should be okay and should give you a sufficient satisfactory result. Because, you know, computers, they're stupid, and when you do some things with numbers, sometimes they make mistakes because they're not accurate enough, because they have a limited amount of space where they need to perform numeric calculations. So if you are beyond the range of safe integers, you are responsible for your own result, and it will not end well. There's also max value, which is the biggest value that actually the language can support in a 64-bit number. So this is the number here. And there's min value. This is not the minimum number. It's not the smallest number that the language supports, but it's the biggest accuracy to 0 that actually a number can be. Like the smallest, tightest, closest to 0 that JavaScript can represent. So these are these two numbers here. So these are the range of integer numbers. Oh, there's the demo. Okay, let's take a look at it. First, the code. Not this one. So there is an external JavaScript file here called JS console, this one, and it comes with its own CSS, and we have a div on the page which is console. There are many demos which are built with those files in the background, and what it gives us is actually, if we look at the browser again, it's this black box into which we can write things comfortably with JavaScript. It's not something standard. It's something built for this demo. So then what we can do, we can call the method jsconsole.writeLine from this JavaScript code. If you want, we can take a look at it later, but it's not relevant. It just gives us a tool to be able to dump data to the screen as if it was a console. So for example, here we are writing to the console. Here we have a variable called student count and equal 5, and then we are writing here a string, and we are concatenating this variable to it. So when we look at it in the browser, oh, what the hell? Here's the output. So we can write lines like this. It gives us a way, a comfortable tool to seeing what's happening and what we're writing. So again, we have these variables again assigned. And what happens is that we're trying to calculate things out of the max integer. And you see what happens here. This number and this number, they look the same. Because once you exceed the max integer or the max integer range that we talked about, then you're on your own. And there are all kinds of oddities with calculations. I think we'll see a few more of those later, but that's basically what I wanted to talk about. Maybe in some points it will. Depends on your calculation. It's not safe. It's called the safe integer range, and if you exceed it, I don't know. It's a computer. They're crazy. Floating point types are more Well, like I mentioned, numbers in JavaScript, there's only one type. It's floating point types, but they are represented differently if you're assigning an integer, if you're using an integer like we did now. But basically, floating point types are the representation of number in floating point is more complex. I have a recorded lecture about floating point types and a whole blog post about it. So if you want to really understand how floating point types are represented in memory, there are different types of how a floating point number is constructed. But again, floating point types, it's the ones with the dot, you know, the decimal point numbers. And they can behave very badly. They depend on the implementation of the on the memory allocation, on the OS, on the browser context, and those can behave in different contexts. They can behave badly as well, depending on what you try to do with them. So again, they have a range here, depending on the implementation. I'm not going to dive into how exactly they're constructed, but here's an example. Notice that what we have here is two variables that we're assigning 0.1 and 0.2, and we have 0.3, and we're trying to see here if this variable and this variable equals to this variable. And maybe, I think the next thing is to show it and see what happens. So first the code. So what we can see here is a few examples to floating point numbers. Math.py, as I mentioned, math is the mathematical library that allows you to do all kinds of mathematical functions and also contains all kinds of constants. So pi is one of them. I think you're supposed to say p. And we're printing it out to the screen. We have the number min value and max value. We'll see them in a second. We have a division by 0, which will give us math.infinity, or minus infinity if we're doing minus pi. And yeah, this is the example we saw in the slide. We have the minus 0.1, 0.2, and 0.3. And let's see what it looks like in the browser. Okay. So here is the pi. Here is the min value and the max value of the floating point numbers. If you divide by 0, you get infinity. If you divide a negative number by 0, you get minus infinity. If you try to do infinity divided by minus infinity, you get already completely crazy. So it says it's not even a number. The epsilon is the E number, and here we have 0.1, 0.2. But if we combine them, if we do this plus this, what we get here is an inaccuracy which comes from the way that floating point numbers are represented, and that could lead to errors. So you have to be very careful when you're dealing with floating point numbers. But you don't need this because you're not working in a financial company or something, so it's not relevant for you. You don't deal with numbers anyway. It's if you want to open. So like I said, if you want a bigger view at floating point numbers, you can go to this blog post, and there is a whole explanation of how floating point numbers are broken down and how they work up to the bit level, and there's a whole example, and also recording which was done here in the academy at some point about numerical systems and how they work and why these things sometimes fail to represent when you try to add something that looks trivial. Just know that it can be tricky. So numbers in JavaScript, there's only one object called number. There's only one data type called number, and numbers are double precision, meaning 64-bit floating points, like I mentioned. There are ways to convert numbers between different types, and there are various ways to achieve this. This is a common trick, and it's quite cool. You see here that we have a floating point 8.75. We take this number and we do a bitwise OR 0. It's a cool trick, but we haven't talked about bitwise operations. Basically, what happens is that bitwise operations work on 32 bits, so this number will be truncated into a 32-bit number, and when this is done, it actually gets converted to an integer. So this is a cool way, and it's actually quite performant if you want to perform it. It's performant if you want to do it, because it, I don't know why, but it is. So just remember that it is, but it's tricky because it can kill your numbers. So this is doing it again. So we're taking the number and we're adding in 0.5. So first we're incrementing it to 9 point something, and then we're doing a OR bitwise OR 0, and what we'll get is the whole part 9. Again, JavaScript is has sometimes can allow you to do many actions that you can't do in any other language so easily. So what we can see here is that we're taking a string and we're converting it into an integer. So what happens here is, again, we're doing this trick of bitwise OR 0. This will take the number and convert it into a 32-bit number, and then it will add 1. So we have two things happening here, two actions. I think, yeah, let's see this, and I think I have another demo or two to show on top of that. We saw this. Yeah, we saw this. No network. What I wanted to show also is this tool called JsFiddle. Yeah. You mean here? It will, let me think. I think I'm not sure if it will concatenate it or convert it to a number and then add 1. But since I just opened JsFiddle to show it also, because it's a cool tool, JsFiddle is one of the online tools that allow you to play with JavaScript. There's also another tool called Plunker, which is widely used, and there's also JSBin, but I like JsFiddle. It gives you a part with HTML, a part with CSS, a part with JavaScript, and you can immediately see your result. So, for example, let's take this. Oh no, what did I do? Put this here. Now about this, a conversion between floating point numbers and integers. Let's see, because I have it here on my fiddle. So there are a few ways to do that. First of all, we can use mathematical functions. These are the mathematical functions that they are the easiest ones to use, and they're the most trivial and the most useful and usable. So you can use floor to round down, or you can use the ceiling to round up, or you can use round, which will round either up or down, depends on your number. So this is how we take this number, and it's rounded down. It's rounded, yeah, it's rounded down with the floor method. Here it will be rounded up, so we get the number 4 in the end. Here it's rounded down because we have 0.35, we'll get it to the floor number, and here it will be rounded up because we have 65, and it's rounded to 664. Another way is to use the bitwise operator OR. This seems weird, and the reason that it seems weird is because it's weird. Yes, that's the reason.
we haven't spoken about bitwise operators yet, but I guess most of you are aware that they exist, and they look like pretty much the bitwise operators that you're used to see. As I mentioned, data in variables is stored in binary format, a bunch of ones and zeros. There are logical operators like AND and OR that are used in conditions and loops when we want to check something, whether some things are acting the way you need to, and you can use those logical operators. There are also bitwise operators that take your data representation in bits as it is in memory and will transform them according to the logic of OR and other options like NOT or XOR. So what we're doing here is we're taking the representation of this number and we're doing a bitwise operation of OR. This line here represents the OR logical operation with the number 0. And what it does is actually it should leave the number as it is, because when you do OR with a 0, I think I'm right, you shouldn't change the value, because 0 or 0 will end with 0, 0 or 1 will give you 1, and 1 or 1 will give you 1. So 0 should not change the value. What it does actually with JavaScript, bitwise operations work only on 32-bit numbers. So when you do a bitwise operation, you actually cut the number into 32 bits and you get rid of part of your representation. This will give you an option to take a number like this, and if you do a bitwise operation or 0, you'll get the number rounded into a whole number integer. Again, it looks weird. It's a weird thing to do. It's not intuitive, and it doesn't always work. Because, here's an example, if the number is big enough and it's beyond the range of 32 bits, what will happen is that you'll lose your number completely. Because here's the result of doing this with this number. This is what you'll get. Because you get a cut down representation of your number into 32 bits, and that's it. Basically, it stays the same, but some just chunk of it is thrown away. And then it becomes an integer, but you don't know what integer it will become. If I take the same number and I do a mathematical operation, matfloor, we'll get the right result. So what I want to say basically is that what you see here is weird, and don't do it. Unless you want to really mess with somebody's brain, look at your code and they'll say, what the hell is going on? That's how you do it. Okay? So I'm not sure why the examples here are sticking just to this example of doing this, but that's maybe to mess with your minds and ask questions. So I already gave you the answer. Black magic. Yeah, it is. Here's an example of how you can take a number and convert it to, how you can take a string and convert it to an integer. Again, this is not how I would do it, but once you make a numerical operation on a string that contains a number, JavaScript will be smart enough or dumb enough to try to follow what you're trying to do and convert things for you. The same goes if you take a number string and concatenate it to some string which doesn't contain a number, it will be converted to a string. So this is also a way to do it if you want to mess with somebody's brain. But that's not the best way to convert numbers into strings or strings into numbers. The right way to do that is to use the method called parseInt. So once I run this, we'll get the number. Well, it's a number now, but you don't know it's a number because it's going to be a string once it pops up. So let's add some numbers to it. But something that you will see that's happening. So I'll put a normal number here. And I'll add it to a number. And we get the sum of the calculation because what we've done here is converting this string to a number with a parseInt method, and that's the best way to do that. If you try to parseInt something that doesn't contain a number, for example, string which is not numerical, you'll get not a number. And if you want to check whether what you have, for example, if you take some, if you take some user input and you want to check whether the user has entered a number or not, you can try to parseInt, and then you can check whether is not a number. And in this case, it will return true. Okay, so again, this is the common way to convert strings to numbers, integer numbers. There's also a method parseFloat, which does the same for floating points. And there's a method is not a number that will help you determine whether the number that the text, the object that you have converted into is a number or not a number. So where were we? There's a demo, another demo. Is there? Not sure, but there's something we haven't seen. We're moving on from numbers. Anybody wants more numbers? Okay. Sure. Well, the question is whether there's a type for currency or we should use floats. As far as I know, there's no special type in JavaScript for currency. Just. Yeah, it's not very accurate, but you have such quirks in other languages too. You'll get calculation abnormalities in C# as well. It's not about the language, it's about the representation of the number in memory. And as far as I know, there is no special variable type for currency in JavaScript. I'm 96% sure of that. I should say 96.6. Okay. Boolean types are simpler types than numbers because they contain only true or false. They're used to any kind of logical tests. So we want to check whether a certain condition exists. You can check and you'll get a true or a false. So of course you can define any variable, give it a name, and set it immediately to true or to false. The keywords are okay in this language, and they are both lowercase in JavaScript, unlike other languages. So, for example, we have two variables here, a and b, 1 and 2. They are integer numbers, and we are assigning a third variable here, which will get the condition, which will get the result of this check. And this check will check whether A is larger than B. And in this case, it's not, so the result will be false. There's also a check here, another check if we want to check whether something is equal to something else. I think we're going to have more discussion about conditions and logical operations and conditional blocks, but in case you want to check whether a certain element is equal to another element, you do it with a double equal sign. Yeah, you know that also from other languages. So if you want to assign something, you use a single equal sign. If you want to check whether a certain condition, whether a certain element is a certain object is equal to another, you use a double equal sign. So in this case, we're checking whether A is equal to 1. It is. So we get here a value of true on this side, and we're assigning it to this variable. And what we'll get here in the output is true. Yes. Just as we saw on the slide. Something is not right here. Okay, so we're using the same console thingy that I showed earlier, just to write down the expressions instead of using the actual console of the debugger of Firefox. And again, here are two variables. Here's our condition. We could actually see how it runs here in Firebug. It would be maybe it will be useful for now, maybe not. So when we load, we get to our breakpoint, and right now we can see the value here is 1, the value here is 2, and the value of this expression, well, it won't show it, but if I go and make a watch for it, we can see the value is false. And when we assign it to this variable, we'll see that it's assigned the value, false. And we'll write it down in the console, this string, and this variable, which is a Boolean, but it will be converted to a string. So once we type it down, we'll see that it's converted to a string, and it's writing false on the screen. Same here, we want to check whether A is equal to 1. And here's the value. I'll copy it here, put it for a watch, and it's equal to true. And once we type it down to the screen, next we get it here, and then we print it down here. And that's what we get. Okay. One more thing that I'm not going to cover right now is just to mention quickly that just a little anecdote right now, that there are two ways to check in JavaScript whether objects are equal. One is to put 2 equal signs, and one is to put 3 equal signs. If you want more equal signs, that's up to you, but 2 and 3 are what you should use. A deeper comparison of objects can be done with a triple equal sign. Just to mention that, because I think it will be mentioned in further sessions, but for today, for now, I'll just want to quickly say that because it wasn't mentioned here. Strings, also very useful. By the way, what you have here is the quote of the first phrase of the Bible. Yeah, I don't know. In other languages, maybe, but this is the first phrase of the Old Testament. In the beginning and all that. So strings. Strings, as we've already seen, are representing a sequence of characters. They're used to store text. They're very useful, of course, for anything pretty much that you might want to build. They can be in JavaScript. They can be both with a single quote or a double quote. So it all, of course, depends on what you need to store inside. Sometimes if you want to put a double quote and you want to make your life easy, you wrap the string in a single quote and vice versa. JavaScript doesn't care. Concatenating strings is also a very easy thing to do. It's very difficult to see the bottom of the screen, but you just use the plus sign and you can concatenate strings into one longer string. What we see here is absolutely nothing new to what I just said. We have an example of two variables. They're both defined as strings. And we are concatenating an actual literal string to a variable which contains a string and to another string, so that we can build our strings like that. Of course, just like any other modern programming language, JavaScript works with Unicode, so you can store strings in any format, in any language, with any symbols. And as you can see here, you can also make your variables Unicode. I've never seen anyone do that, and I wouldn't recommend it, but it's seemingly possible. Because I mean, okay, maybe this is okay, but if somebody makes this a variable down here, it will be more difficult to read for some. Let's see some examples. Well, not much to see here, just as we saw in the previous slide, where what we're doing, we're concatenating strings. So we have here an actual literal string that we're concatenating with a variable. So we have to enclose our first string with double quotes or single quote, and then we can concatenate strings with plus signs. And that's how we can take a variable that can come from the database, from the server, from anywhere, from the user input, and we can concatenate it into one larger string. And this, of course, one of the most useful things to do for any application. Once we have concatenation, of course, it's a common mistake. You need to put spaces in between, because nobody will do it for you. So once we concatenate strings that we need to be spaced between, we need to also specify that they're spaced. Otherwise, they'll be in one long one. And these are some Unicode representations also of variables. And you can see that they all work. So you can use Unicode pretty much anywhere you need. Okay, about strings, have a little bit more to go. Undefined and nulls. We'll start with the easy one. Null is usually a value of an unassigned variable, so that okay, so once we have a variable and we don't assign anything into it, we can also manually assign the value of null. It means that the variable is defined, but its value is currently empty. It doesn't contain anything important or anything at all. If a variable variables can also be undefined, or if a variable is really not defined in the scope of your code, you can check whether it is equal to, if its type is undefined. It's something unique to JavaScript because variables can come from anywhere, and names of variables can be coming from your global scope or from external files. And since JavaScript is not compiled, if JavaScript was a compiled language, you would get errors in your build. Once you try to build and compile your code, you would get you'll get compile time errors that you're using a variable that doesn't exist, or that you're using the wrong name, or things like that. But JavaScript, of course, is not compiled. It's only interpreted in runtime, and variables can come and go from different places. And one example of that is that different browsers implement JavaScript differently. And for example, when we try to interact with our DOM document, when trying to interact JavaScript with the HTML, in some cases, some browsers will define certain objects that you can interact with, but other browsers will define them differently. So in some cases, you can try to check whether the variable you're trying to access is undefined. It means it's not existing at all for this browser, so you shouldn't interact with it. So that's one of the usages of checking whether something is defined or not. I mean, in your code, there should not be, I mean, in the code blocks that you build, there should not be undefined elements, basically. But you can check whether external things that you're using, for example, integration with the browser objects that are given to you are defined or undefined. So that's the importance of undefined. Which, by the way, if I go back to my notebook, if I check something like this, I'm just jumping ahead to conditional statements just for a moment. Don't like it like this. That's better. So if I have an if block like this and I'm checking this variable, it will be checked whether it's defined and whether it has some value. I mean, if it's null or undefined. So we can see that. I'll just show it in a moment. So I'll put two alerts, one here and one here. Just to see the result. Oh, no, don't save. So since the variable x is currently undefined, we're not getting anything at all. Okay, let's try this somewhere else. Still not. Okay. Surprise. Well, something is wrong here because okay, forget about this example. It's not working as I expected, although I have to check why. But actually, just a moment, sorry about that. Let's take a look at this one. Okay, so what we have here is, again, we're defining a bunch of variables, and what we're typing is the output of the method type of, which will give us the type of this variable. So in this case, you can see that once we define an integer or a floating point number, both of them are represented by the type number. As I mentioned, they're all underlying the same representation in the language. Then we have a variable. Actually, we are using the same variable again and again. So we are just giving it different values. We can manually set a variable to be undefined by setting its value to the keyword undefined, and the type will be undefined. We can set it to null, and then the type will be actually an object, but it's an empty object in this case that can be used as properties. Then we can set it to a string. Then the type that will be detected is a string. And as I mentioned, you can use the object which represents a number by using a constructor and using the keyword, the class name number. Then you'll get an object, but as I mentioned, it's pretty useless to use object numbers, number objects. I think that's about it for this part. So variables are pretty much what we've seen since the beginning today. Storing data and storing information. It could be any of those types that I just mentioned, not counting classes and objects that we still haven't covered, but all the built-in language types like numbers and strings, undefined objects, and nulls and numbers. So as I said in the beginning, we have the var keyword, which defines a variable. And once you define a variable, if we're talking in terms of code blocks, once you have a variable, it's alive within the block of the code in which it's defined. So here's the notation. You put the word var, then you set an identifier, and you may or may not initialize it to give it some value. As you can see here, the var, we put a variable called height, and we set its value to 200. Identifiers can be letters, underscores, numbers, digits, the dollar sign, and it's not exactly true that it can begin only with a letter or underscore. It can also start with a dollar sign, and this is used, of course, in jQuery. jQuery has taken advantage of using the dollar sign as a named variable, so it's actually the entry point to using all the jQuery functionality using dollar. And it's also common practice here and there, whenever you have a variable which is initialized with something that comes from jQuery, to start its name with a dollar. So you will know that this is a variable which relates to jQuery data. Of course, you can't use keywords as variable names. You'll get in trouble. And the notation of variables, whether it's camel case or something else, is up to you, but standards are with camel case, which means the first letter is lowercase, and if you have multiple words, you put them together with an uppercase letter. It goes without saying, when you're putting variables, give them names that have some meaning, so especially something that will be in context of what they're used for, so that somebody comes to see your code will understand why you're using a variable there and what's the meaning of it. Don't put it too short, don't put it too long. Use Latin letters, because you don't know who's checking your code. And variables are case sensitive in JavaScript, just like in C# or Java. So you need to be aware that your variables are used with the right casing. So some examples, we have some variables here, not much to show. As I said, you can use any name. This one would stand out because it has an uppercase letter starting. It's not very common. But if you use a lowercase new, then you'll get in collision with a new keyword which is used in JavaScript, and that will be a problem. You can begin a variable with an underscore, but if I would remove the underscore here, I'll get a variable which starts with a number, and that would also be a problem. You can use Unicode, as we saw, to define your variables, but it's also not recommended. So the good way to do this, put a var, give it a normal name that somebody will understand what it is for, and initialize it, and with the right appropriate value so it won't get completely lost, and that's it. No. So great, this demo doesn't have an output, which is the best type of demo in the whole world. So, instead of a black screen, actually what we see here is a copy of what we saw in the slide. We could take a look at what's going on in runtime just to cover it. So here's our code. Let's reload it. So over here we can see that the watches of Firebug is already analyzed the code, and it gives us some of the variables that we're using here already lined up. So once they get assigned, for example, this one, and can you see anything? So once we run this line, we can see that this is already initialized, and we can see its value, and so on and so forth. We can see now that the values are being assigned to those. By the way, I wouldn't necessarily consider this an over-descriptive identifier. Sometimes it's needed. I'm a fan of long names that tell you exactly what they're for. Okay with this? So as we've seen already, we're a bit repeating, assigning values to variables with the equals operator. You can do it while you define the variable. You can do it any other time. Once the variable is alive, you can reassign values to it. So here we have 3 variables, and we start reassigning values to them. What's interesting here, by the way, yeah, in this case, what we have is a copy of the value between the variables. So we have the first one initialized, and the other 2 not. And once we have them running, we can reassign values between them. We can also do a three-way assignment, like down here, although it's not very intuitive, so shouldn't be used. I actually have never seen. I haven't seen much three-way assignment like this. It also works in other languages. I haven't seen it much used, and I think I know why. Anything special to say about this slide? No, so much. So here are some examples which are pretty similar to all the examples that we've seen so far. Assigning variables with the var, name, value, and reassigning them between themselves. I'll just skip to the next one because I don't think there's any more to keep talking about assigning variables. The only thing I want to mention here is the fact that you can assign variables, as I mentioned in the beginning, with the var keyword, but it's not necessary to use the var keyword. You don't have to use it. You can just take a variable and start assigning it. The point is that if you assign a variable without the var keyword, since JavaScript will not know where it's actually coming from, it will treat it as a global variable, which means it will live beyond the scope of your code blocks. Sometimes it's useful. For example, if you're building an external library like jQuery and you want to build some kind of a global thing that people can reuse, then you can define it maybe as a global. But in most cases, once you define variables in your code, they have a specific lifespan, a specific area of the code where you need them. So in this sense, you have to think where you're defining them and give them the var keyword in the declaration so that they're alive only in the scope of their own code. Also, you have to be aware of double declaration because you can redefine a variable once it's there. Again, JavaScript will not care about it. It will not give you a compile time error that you're redefining a variable because there is no compile time. And it can give you a problem if you're not cautious enough and you're giving a variable, you're redeclaring variables in your code with the same name in the same scope. I think that's all there is to it. Questions? This one? Yeah, except that here it says var, and here you're just defining the variable without var, so it's becoming global. So you don't know what you're running over, and it's a problem. And by the way, yeah, if you define a variable with a var which collides with a global variable which already exists without the, a global variable that your code block has gotten, I think it will not get overridden. I think so. Let's check it out just in case, because I had some surprises today. But that's the whole idea, right? What I want to check is this. So, let me think about something. I want to put a code block here. And another variable with the same name out here. And I want to see what will happen here. And what will happen here. So we get the variable from in this block, which is defined with a var and should cease to live outside. And we actually overridden the global variable. So be careful, because variables can be redefined and overridden. I think in a function it will behave maybe better, because functions are actually defining also classes in JavaScript. Oh, no, don't give it the same name. Let's see now. So instead of just running through the code, I've defined a function, and now I'm calling the function, and once we're done, we're back to the external scope. So now we get the inner function code running, and now we get the outer. Yes, good catch. Any more? One of the lessons from the HTML course that people gave a feedback that they needed more exercise to do on their own. So we're sharing now in the Academy's Knowledge Hub those PowerPoint presentations, and in the end there are exercises if anybody wants to try to play with things themselves, because we don't have much time to exercise in those sessions. Questions from you before we close it for today? Okay, so thanks guys. See you next week.